Hello everyone, welcome to YouTube channel MS Cam Insights by Dr. Aksa Habib. Today I am going to discuss heterogeneous catalysis. Heterogeneous catalysis is a special type of catalytic process where the catalyst and the reactants are in different phases. The catalyst is usually in solid phase while the reactants are either in liquid or gas phase. Here is an example of formation of sulfur trioxide from sulfur dioxide and oxygen. The gaseous phase reactants get adsorbed on the surface of solid platinum catalyst, and this catalyst provides the active site for the reaction between these gases. After the reaction, the product gets desorbed from the surface of metal catalyst. Thus, the catalyst is regenerated without any permanent change. Here are some key features of heterogeneous catalysis. As I have already discussed that the catalyst and reactants in heterogeneous catalysis exist in different phases. Thus, it allows for the distinct interactions between the reactants. As the catalyst is different in phase from that of reactants, thus the catalyst provides a site for the reaction, making the surface area of the catalyst an important factor to facilitate the transformation of reactants into products. Heterogeneous catalysis is advantageous from industrial perspective as after the reaction between the reactants, the catalyst can easily be separated from the products. The most common applications of heterogeneous catalysis are found in Haber's process for the synthesis of ammonia from hydrogen and nitrogen in the presence of iron catalyst, and Ziegler-Natta catalysis for the polymerization of unsaturated hydrocarbons or olefins. I am going to focus on the Ziegler-Natta catalyst, which was discovered by Carl Ziegler and Giulio Natta in 1955, and it is a special type of coordination catalyst which consists of two components, that is catalyst and co-catalyst for the polymerization of olefins or unsaturated hydrocarbons. The catalyst is basically an electron-rich species, and it consists of halides of group 4 to 8 of d block elements. And the co-catalyst is an electron deficient species, and it consists of organometallic compounds of group 1 to 4 with alkyl, aryls or hydrides. The most common combination of Ziegler-Natta catalysts consists of triethyl aluminium with titanium tetrachloride. This combination is insoluble in solvent, thus it forms heterogeneous system. Now I will discuss the mechanism of Ziegler-Natta heterogeneous catalysis for the formation of polymers from unsaturated hydrocarbons. Although this is a continuous process, but for the sake of convenience, it can be divided into different steps which have been discussed over here. In the first step, the co-catalyst get adsorbed on the surface of catalyst by chemisorption process, thus results in the formation of electron deficient bridge complex which provides the active site for the propagation of polymer chain. In the second step, the monomer is attracted towards this active center where it forms a pi complex with the titanium metal. In the third step, the bond between titanium and alkyl group breaks, thus forming electron deficient titanium metal and electron rich carb anion at alkyl group. In the next step, titanium metal attracts the pi electron pair of monomer while the carb anion attracts the electron deficient center of the monomer, which is then inserted into the transition state ring. In the next step, transition state rearranges itself and thus gives rise to chain growth at metal carbon center and regenerating the carbon titanium active center. In the final step, the repetition of the previous steps occurs by the incorporation of an incoming monomer, which results in the formation of stereoregular polymer by moving the previous monomer away from the ring, which carries the alkyl group of the catalyst. Thus, Ziegler-Natta catalysis provides a foundational technology in the field of polymer chemistry, enabling the production of a range of materials for different applications. This was all about heterogeneous catalysis with specific focus on Ziegler-Natta catalysis. If you have any question or query, please drop a comment in comment box or drop an email to me on the email ID given in the start of this presentation. Thank you very much for your attention.